Hi, my name is Ishan and welcome to Easy Math. In the last video, we saw completing the square method. And today we're going to do a few questions from quadratic equations, the chapter. And let's see, this here is an exercise which contains a few questions. There are different kinds of quadratics here for all the sets here. For example, set number 1, set number 2, there are going to be different techniques that one has to use. I'm going to solve a few for you to understand. It's kind of difficult to make you understand without actually doing it. So here we go. Let's see. Look at one part C. That's the one we're going to do now. So here we are given 5y square minus a 28y plus a 15 equal to 0. Well, for me to solve this, I'm going to simply go and use the quadratic formula for it. So I go y equals minus b plus minus root over b square minus 4ac divided by 2a. Well, when it comes to the general form of quadratic, this is what it is supposed to look like. A here is a 5, b here is a negative 28, and c here is a 15. So I'm going to only go and substitute these values. Negative b is a negative 28 plus minus square root of b square. That's again a negative 28 minus a 4 into a into c divided by 2 times a. Common mistake here is to ignore the fact that you have a negative 28 as b. You may go and simply write a negative 28 here in place of negative b there. That is wrong. B should be replaced by a negative 28 in brackets, and that negative should stay like that. Okay, so that's one thing one should keep in mind. And from there, y would come out to be plus 28 plus minus square root of 28 square. I think that's a 576. Let me just check once. 28 square, that's a 784. 784 minus 16 to 5, that's a 300 divided by 10. It comes out to be 28 plus minus square root of 484. That's a 22 divided by 10. So that's a 40 divided by 10 and a 6 divided by 10. 28 plus 22, that's a 40. 28 minus 22, that's a 6. And that is why y comes out to be 4 and a 3 over 5. This reduces to a 4 and this reduces to a 3 by 5. Well, that's your the quadratic in the one part C solved. These are the two y values. So all we had to do was to use the quadratic formula. Well, if you are looking at one part D, it's a 4z square minus 49 equals to 0. Now, if you want to use the quadratic formula for this one, not a bad idea. We can go compare this with ax square plus bx plus c equal to 0. A here is the term that is with z square. That's a 4. B is supposed to be a term with a z, but there is no such term here. So B is a 0 in this case, and C is a negative 49. And now you can go use the quadratic formula. Z is going to be equal to minus B plus minus square root of B square minus 4AC divided by 2A. Well, that will be a 0 plus minus square root of B square is again a 0 into A into C, that's a negative 49 divided by 2 times A, which is a 4. So Z in this case comes out to be plus minus square root of 16 into 49. 16 into 49, that's what it is. And divided by 2 into 4. Well, trying to find out the square root of it. Square root of 16 is a 4. Square root of 49 is a 7. So 4 into 7 is what you're going to end up with. That's a plus minus 28 divided by 8. Well, that's a plus 14 or a 7 by 2 and a minus 7 by 2. Well, that is the quadratic formula way of doing it. Remember, the b value is a 0. There is no z term in here. it's either a z square or there is no z at all. There's no z with just, with no powers on it, like a z, just a z. Okay. That's the quadratic formula way of doing this question. How about we do something else and still get the same answer? Well, tell me, if 4z square minus 49 is a 0, 4z square will come out to be a 49. Well, z square in that case will come out to be a 49 by 4, and that gives me to a z equals square root of 49 by 4. Remember, you need to put a plus and a minus out there. Well, z again in that case would come out to be plus 7 by 2 and a minus 7 by 2. That's also an easier way of doing it. When there is no z term, it's kind of easy to, there's no linear z term, as in there's no z raised to a 1 in your expression. It's easy to solve quadratics. Well, that was about your question number 1. Now let's go and do some other question. How about 2-part D? Well, 2-part D, if I try to do, I see it's a 7 minus 3k whole square equals 9 over 16. Well, I'd go square root both the sides. 7 minus 3k in that case would come out to be plus minus square root of 9 by 16. Well, that's at 7 minus 3k equals 3 over 4 and a plus minus there. Well, minus 3k would come out to be a plus minus 3 by 4 minus a 7. Well, minus 3k in that case would be a plus 3 by 4 minus 7, and a minus 3k will also be equal to minus 3 by 4 minus a 7. I'll take a plus 3 by 4 once. That's one solution, and from there I can do a minus 3 by 4 minus a 7. That will be another solution. I can go minus 3k equals, solve this. That's going to be a minus 25 by 4. K in that case will come out to be minus 25 by 4 into negative 3. Well, that would be 25 by 12. Well, 3 by 4 minus 7, I don't think I need to tell you how to do it. In case you are not sure about it, I would like you to do it on the calculator. Here, minus 3k equals, this is going to be minus 31 by 4. K in that case comes out to be a 31 by 12. Why? Because this 3 comes down here in the denominator, multiplies with the 4, gives you a 12, and the minus would cancel out. So all you're looking at is 31 by 12 and 25 by 12. Let me check if my answer is correct. So you go 7 minus 3k whole square equals 9 by 16, and 7 minus 3k equals plus minus 3 by 4. That is correct. Minus 3k goes through all of this. Yes, that is correct. Okay, so that was one part D. So the idea here is to square root both the sides. If you have a perfect square on the left, you simply square root both the sides. In that case, you are left with a linear term on the left, a 7 minus 3k, like you had a 7 minus 3k here. The moment you square root both the sides, you square rooted these two. There, done. Okay, so that was about 1-part D. Now let's do 3-part D. Well, in this question, I'm supposed to bring x square minus 2x by 9 to a form x plus r whole square plus u. Well, questions like these are to be done by the method that I discussed in the previous lecture. It's literally completing the square method only. Look at the coefficient of x here. It's a 2 by 9. Divide that 2 by 9 by a 2. You'll get a 1 by 9. X square minus 2x by 9. Dividing the 2 by 9 by a 2, you get a 1 by 9. What you do here is you introduce a 1 by 9 square minus a 1 by 9 square by yourself. Now these three will turn into a perfect square. Remember, x, because there's a x here, a negative, because there's a negative here, a 1 by 9 only, and the whole thing squared. That's how you would reduce all the three terms, first three terms, into a perfect square, and now you have a 1 by 81. That's your answer for the 3-part D. We can also do 3-part H now. 3-part H. Well, it's a negative x square plus 11x. Remember, is one added step here for us to bring it to our x plus r whole square plus a u form. Well, I'm going to take a negative 1 out. Now it becomes a x square minus 11x. From there on, I can go do a negative x square minus 11 by x. In the bracket here, I'm going to introduce a 11 by 2 square minus a 11 by 2 square. And now, like it was in the previous one, these three will reduce to a perfect square. X, because there's a minus here, we've put a minus here also, 11 by 2 whole square minus a 121 by 4. Now that's a negative x minus 11 by 2 whole square. Open up this bracket, minus x minus 11 by 2 whole square, plus this negative, that negative, plus 121 by 4. That's your answer. That's 3-part H for you. Now we can do 4-part D. So you go x square minus 2x by 7 plus r 7 and bring it to the form x plus r square plus r u. Well, uh, again, I see there's a 2 by 7 there with x. I'm going to halve that, becomes a 1 by 7 square minus a 1 by 7 square. These are the two terms that I'm going to introduce by myself. And of course, the first three terms again would reduce to a perfect square. It's going to be a x minus 1 by 7 whole square minus a 1 by 49 plus a 7. And now you go x minus 1 by 7 whole square. And my negative 1 by 49, negative 1 by 49 plus a 7 can be done on the calculator. It's a 342 by a 49. Well, that's your square form done again. That again is is completing the square form, and that's about it. We can go do the part E now. 3-part E. We go negative x square plus 10x minus a 2. Well, again, an added step because the x square has a negative 1 as its coefficient. I'm going to take a negative 1 out common. It becomes x square minus 10x plus a 2. And now look at the coefficient of x here. It's at 10. I'm going to introduce a plus 5 square and a minus 5 square by myself. These are going to reduce to a quadratic. X minus 5 whole square, it'll be minus 25 plus a 2. That's a negative x minus 5 whole square minus 23. And now you can open up the larger bracket. This bracket you can open up. It becomes a minus x by 5 whole square plus a 23. There it is. Done. So that was 4. Oh, did I forget some? Oh yeah, that was 4-part E, sorry. This was 4-part E. There. Now we can go do 5th one. Here, they want us to solve each of them by completing the square. Okay, that is something that we have learned, but I'll give you an example. P square plus 4p, p by 4 minus a 3 equal to 0. Completing the square for it, I see that the coefficient of p is a 1 by 4. Half that, it is a 1 by 8. So p square plus a p by 4. I'm going to introduce a 1 by 8 square minus a 1 by 8 square minus a 3 equal to 0. Now these are going to be a perfect square. P plus 1 by 8. Remember, if there's a plus sign in between the first two terms, you're going to have a plus sign here also. Minus a 1 by 64 minus a 3 equal to 0. Now that is supposed to be P plus 1 by 8 whole square. And that's a negative 1 by 64 minus a 3 comes out to be negative 193 by a 64 equal to 0. And I find it weird how it's not a perfect square, this thing. But again, we'll see. P plus 1 by 8 whole square. Now, that was the square form done. Now we're solving it. Comes out to be 193 by 64. Now, P plus 1 by 8 is going to be plus minus square root of 193 by 64. I don't think square root of 193 is a thing. Oh, yeah, they wanted it in, they wanted two decimal places. No, they want two decimal places. I can do it. Square root. So we can go square root of 193 divided by 64. That's a P plus a 1 by 8 equals 1.7365. So 1 by 8 is a 0.125 with a plus minus out there. P in this case is going to be a 1.7365 minus a 0.125, or a P is going to be negative 1.7365 with a negative 1.125. Well, this would come out to be 1.61, and that is going to be a negative 1.86. Done. Those are your P values. So after you have completed the square, it's just the part here, the 193 by 64, which was supposed to be taken to the other side. And then you had to take the square root of it, find this from the calculator. This part of it needs to be found from the calculator. And that's about it, That's it. Now look at the sixth one. Sixth one, they want you to bring the square form x square plus 17x plus a 30. See, what I do now is I'll let you do these questions. I'm going to mark the questions that you should be able to do. Well, you should try this one, and this one. Remember, if there's a decimal, a 0.2x, trying to achieve that form, half of a 0.2, which is a 0.1. So you're going to introduce a plus 0.1 square minus a 0.1 square here. X square plus a 0.2x plus a 0.1 square minus a 0.1 square. That is what you're going to introduce. And from there on, I think you should be able to do it. This one, if it doesn't come along, you can do this one also. And you can tell me about it if it doesn't make sense. You can do one more, maybe this one and one over here. And of course, the 6 and the 7. Now, even if you do half of what I have ticked here, half of what I have suggested here, that's good enough. One or two questions from each of the parts is good enough. Okay. Coming to one part B, I would like to say that this one and this one, these two are almost the same. Just remember, you're going to have to bring these to ax square plus bx plus c equal to 0 kind of a form. Only then can you do it. I'll give you an example. Let's look at the D one. It's a 4x square plus 1 equals negative 4x. Well, you can change this to 4x square plus a 4x plus a 1 equal to 0. Now it is in the form, you can solve it using the quadratic formula or whatever method works for you. Same, look at E. You can go 9 minus 5x square equals negative 3x. Well, I'll take these two to the other side. A 0 remains here if I take both of them. A negative 3x, a negative 9, and plus a 5x square. Well, you're going to remain with a 5x square minus a 3x minus a 9 equal to 0. Well, that's about it. Again, from there on, it's easy for you to solve. These kind of questions, I'll do a separate video on. 3, 4, maybe 3, 7. Algebraic fractions is a thing that may be asked in the exam. We'll talk about it later. For now, I'm going to see you. You have a good night. A good day, man. Bye.